Good morning, my geometry friends. Happy Thursday. I'm not sure when you're watching this, but it's Thursday for me. Good morning. We are we're reviewing the first sections of area in Chapter 9. It's going by very quickly. This will be our last assignment for the week, so you can kind of catch up if you've fallen behind. And it's ready to go on 9.1 to 9.3, page 615, numbers 1 through 11 odd, and number 12, because we want to practice that irregular area. So make sure I add that on there. 1 through 11 odd, and good old even number 12. Okay, so I picked out 3 problems that I think would be useful to review with you. Number 5, number 9, which is a regular polygon, and then irregular area number 12. So let's just jump right in and have some fun. Number 5, I wanted to go over because there's just a lot going on here. You have 3 shapes within this kind of mosaic. You have the triangle, you have the trapezoid, and you have the parallelogram. And we have to find the perimeter and the area of each one. So let's go ahead and jump right in there. And I'm going to start with the area on each one of those. So let me just go ahead and sketch each one of these. We're going to find our triangle. And I'm going to go ahead and just sketch it there's the triangle. Then we're going to find our trapezoid. And then we're going to find our parallelogram. Okay, so area of a triangle equals 1/2 base times height. So if you look at that little triangle, you can see that it is actually 2 by 1. I'll write the dimensions here. That'll get a little too messy. But the green triangles have bases of 2 and heights of 1. So we can just plug that in. 1/2, 2 times 1. And so that is going to give us 2 times 1 is 2. Cut in half is that's going to give us an area of 1. And then each of these blocks are centimeters, so that's 1 centimeter squared. All right, so there's our area of our triangle. Okay, let's go ahead and do our trapezoid. I'm going to do all the areas first. Area of a trapezoid is area equals 1/2 base 1 plus base 2 times the height. So we want to go ahead and look at the bases of that trapezoid, and we can see that the base of that one is 2, this is 1, and this is 1. If I'm looking at my blocks here, it goes up 2, 1, 2, the other base is 1, and the height is 1. So we can plug all those numbers in. 1/2 times 1 plus 2 times 1. So 3 times 1 is 3. 3 cut in half is 1.5. So the area of the trapezoid is 1.5 centimeters squared. Okay. Both of these, you could look at the picture and you could make a good guess just based on looking at the size of the blocks. Especially the trapezoid, you can see that it clearly takes up 1.5 blocks. So you can see that's a good answer. But again, I'm working with the formulas, practicing that, because you can't always count on just being able to estimate it with your eyes. Though it's always good to intuitively consider your answers sometimes. Always sometimes. Okay, and then the area of our parallelogram. Now this is an interesting one because the area of a parallelogram is just like a rectangle, base times height. But when you look at how they've put it in here at a slant in the picture, it's really kind of tricky to see, well, what the base is, because the base is a diagonal and the height is, again, obscured. So the base and the height of this particular parallelogram is not clear. So that's why I'm actually not going to use that formula to find its area. For me, I'm going to look at it, and I'm going to reference the specific picture here, as 2 triangles. If I divide it into 2 triangles like this, I can see the base and the height of those triangles really easy. I can see that the base of the triangle, and what it would look like, so I'm going to just re-sketch it, because it looks like this. That if I divide it into 2 triangles, I can see the base of the triangle is 1, 2, 3. The height is 1. Okay, so it's got a height of 1 and a base of 3. So I'm actually going to use area of a triangle and go ahead and calculate that. Area equals 1/2 3 times 1. And so the area of one of these triangles is 1.5. Now, of course, I've got two of them, so I'm just going to double that back to what I had originally. So times 2. And so the area of the parallelogram is 3 centimeters squared. That C doesn't look very good. 3 centimeters squared. Okay, because I could more easily see the base and the height, I almost treated the parallelogram like a composite figure, just to have an easy base and height to work with, where I'm doing half of it was 1.5, and so the whole thing is 3 centimeters. Okay. All right, so we got our areas: 1 centimeter, 1.5 centimeters, and 3 centimeters. So now let's do the perimeters. Okay, I'm going to have to bleed down here. I didn't leave myself enough room for all the perimeters. Okay, so the perimeter, let's go back to our little triangle. If I go around my triangle, I can see, I'm going to just draw it again. Okay, perimeter of my triangle is 2 by 1, and then I have my hypotenuse. What is my hypotenuse? Well, we're going to have to use our Pythagorean theorem to find our hypotenuse like we have. So we're just going to go 2 squared plus 1 squared equals our hypotenuse squared. So that's 4 plus 1, that's 5. 5 equals the hypotenuse squared. So that means my hypotenuse is the square root of 5. So this here is the square root of 5. So my perimeter of my triangle is 3 plus the square root of 5. Now that's the perfect answer. If I plug square root of 5 into my calculator and add it to 3, that comes out to 5.2 centimeters. I do not square it because this is linear perimeter, distance around, and so I'm just going to leave that 5.2 centimeters for the triangle's perimeter. Okay? Notice again, we just had to use Pythagoras to find that hypotenuse, and they wanted us to round it, so I went ahead and crunched the square root of 5 and got that. Okay, so now let's look at our trapezoid. Let me redraw the trapezoid. Good problem because you're getting lots of different practice and all sorts of things. Sorry, I can't draw shapes this morning. Okay, so let's look at the distances around. The height is 2. If I go here, you're going to go here, that's 1. Up this way, that's just 1. And I have another hypotenuse. What is the hypotenuse of that diagonal? Well, it's a nice little triangle. That's 1 by 1. Okay, see, this makes a triangle, a right triangle that you got 2 legs of 1 and 1. So what is my hypotenuse? If you know your special triangles, you immediately know the answer, square root of 2. But we'll work through it. 1 squared plus 1 squared equals my little hypotenuse. And so that's 1 plus 1, so 2 equals hypotenuse squared. So that means my hypotenuse is the square root of 2. Okay, so let's write that in, square root of 2. So my perimeter, notice I think this is more difficult, or at least more work than the areas. That's why I'm doing it second. Is 2 plus 1 is 3 plus 1 is 4. 4 plus the square root of 2. Okay, and if I calculate that, 4 plus the square root of 2, that gives me 5.4. 5.4 centimeters. And that is the perimeter of our little blue trapezoids. Okay, so that then just leads me to my parallelogram. So at first we might be thinking, oh no, this looks like a pain. But the nice thing is we've already done the work. Because if you look at your drawing, the long sides of the parallelogram are the hypotenuses of your blue triangles. Your green triangles. Green triangles are the hypotenuses of this leg. So I already know what this is. This is the square root of 5. And the other side is the hypotenuse of the little blue triangles for the trapezoids, and those are the square root of 2, because we just did that here and here. So those are all my distances. Square root of 5, square root of 5, square root of 2, square root of 2. So I add those all up. That is 2 square root of 5 plus 2 square root of 2. If I wanted the perfect full answer, Once I plug that into my calculator, hit the square root of 5. Well, we'll just do it. This one I'll demonstrate. Okay, 2 times the square root of 5. I'm going to close the parentheses. Plus 2 times the square root of 2, close the parentheses, equals, that's 7.3. So approximately 7.3 is my final perimeter. Again, not square units because this is not area. So there we go. We have our, that should be red, bothering me, my OCD. Okay, we've got our areas, 1 centimeter, 1.5 centimeters squared, 3 centimeters squared, and then our perimeters. Okay, just kind of working through each one. No tricks of anything in particular, but just kind of logically working through using our area, using the Pythagorean theorem, using, again, the way I did the parallelogram, knowledge of composite figures. Okay, I'm going to fence this off, and we're going to get to the area of our regular polygon. Not sure how, let me know how much you're enjoying this, but you can do it. It says number 9, regular pentagon, 5-sided shape, 1, 2, 3, 4, 5, and it gives us the side length. The side length is 12. Okay, so here we go. I'll show you how quickly you can do this. We're going to create that right triangle. Our formula is 1/2 AP, apothem, times the perimeter. I already know my perimeter, 12 times 5. So perimeter, they give you the side. The perimeter is very easy, 12 times 5. So I need my apothem. Okay, and the key to that is going to be, apothem is from the center to the center of the side line. And so I'm going to create my right triangle here because I can find this degree, I can find this, and then that'll allow me to solve for my apothem. Okay, so if you remember, this side length is always half the entire side, so I'm just going to call that 6. And then this angle is always, well, we've got a full circle here, and we have, in a pentagon, we have 5 pieces. So I'm going to go 360 divided by 5, and that tells me the interior angle, 360 divided by 5, that's going to be 72. And then I'm going to go ahead and divide that by 2, because I'm actually really, because that tells me this, because this is what I have 5 of, these big triangles. And then I'm only going to be use half of that. So I'm going to divide my 72 by half, and I'm going to see that my angle that I'm looking for is 36 degrees. Okay? So this is, right here, 36 degrees. So I've created a right triangle, and now I've just got a simple trig problem where I know I've got 36 degrees. Sorry, this is so small. And my opposite is 6, and I need to know my adjacent. Opposite and adjacent is TOA, so I'm going to use tangent here. Okay, tangent of 36 equals the opposite 6 over the adjacent apothem. All right, and then that, as we've hopefully getting more and more practice at, that means my apothem is 6 divided by the tangent of 36, and we can find our apothem. Hallelujah. So my apothem is approximately, I'm always so excited to find out. Hope you're 6 divided by tangent of 36, 8.26. 8.26. And so now I can take that and plug it right into here, 8.26 times my perimeter divided by 2, and I've got my answer. Hallelujah. Now, to be as accurate as possible, I'm actually going to leave that right in there, and I'm going to start solving. So my apothem times my perimeter, which is 6, I'm sorry, not 6, 12, my side lengths are all 12. 12 times, there's 5 of them because we have a pentagon. Okay, so there it is. And then we need to do the half, so divided by 2. And there is my area, 247.7, which is exactly what at least our good old book tells us it should be. So what we did was we did area, actually I'll do it right here, area, fence this off, area equals 1/2 8.26 times 12 times 5, because that was our perimeter. And what that comes out to, the area is approximately 247.7. We are always, put your units on, meters squared. Okay? That's nice solving math with you. Hope you're having a good day. Jesus is good. Weather's good. All right, so there we go. Regular pentagon. Practice these if you feel lost, because again, it's going to be the same process. It's going to be creating a right triangle and solving it using this interior angle, which you can always find by dividing by the number of sides. And then you always cut that in half because you're only using half of that angle. The side length of that right triangle is always half of your side length. And then just what we've learned in trig. And then you plug it into our formula, 1/2 AP. A lot of steps, but all steps you can do, especially once you practice it a few times. Okay, let's finish it up. I wanted to go ahead and add on number 12, so do make sure you do number 12. Practicing irregular composite figures. And so we've got this blob, and I've drawn it kind of small because I tried to draw it to the right number of grid sizes. And so here we're supposed to approximate the area, and then because they're growing grass at $6.50 per yard, we're going to calculate how much it would cost to plant this amazing blob of grass. So first step, we need to, you could sit there and try to count all the blocks, and that would probably get you somewhat close. So it's always interesting to do that. I'm going to show you a little better is to start dividing it into shapes. So when I look at this, I see a triangle on top. I see a trapezoid right here. This looks a little more vertical. This looks a little more diagonal. So I've got a trapezoid. Here I see a parallelogram. Nice long parallelogram. And then on the bottom, I see a real big triangle. A real big triangle. So I immediately fill it up with the shape. So I see, again, I'm going to draw them a little bigger here. I see a triangle. I see a trapezoid. I see a parallelogram. I feel like a little kid book. What do you see? I see. All right, and then we see a triangle down at the bottom. Long triangle. I'm drawing those just so I can put the dimensions in there. Okay? So on my triangle, I see it with a height of 1 and a base of 2. So we're just going to go ahead and 1/2 base times height. So 1/2 times 1 times 2. So the area of that top triangle, 2 times 1 is 2, cut in half, is just 1. And I'm going to add that to my trapezoid. Looks like it's got a top base of 2, a bottom base of 3. Did not draw these to scale. And a height of 1. So 1/2, add my 2 bases, 2 plus 3, times the height of 1. So that is 5 cut in half. And so that's going to be 2.5. I'm putting these little pluses because I'm going to add all these guys together. Plus, plus, plus. All right, my parallelogram is just base times height. And that is, it's got a base of 3 times a height of 1. And so that's just 3. And then I get to my triangle. So yeah, that was 3 by 1. And then my triangle also has a base of 3 and a height of 1. So 1/2 times 3 times 1. Okay, so that's just 3 times 1, cut in half, 1.5. So I've got 4 shapes here. Triangle, trapezoid, parallelogram, and another triangle. 1 plus 2.5 plus 3 plus... Oh, actually, you know what? I'm sorry. Going to look. Actually, my triangle, I'm going to change this. My triangle, if I actually look at this, is 1, 2, 3, 4 in the actual drawing. Yeah, I'm going to call it 4. 3 is close, and if you did it that way, I think it would be fine. But we'll call this 4. And so I'm going to estimate that area to be closer to 4 times 1, cut in half it to be 2. So 1 plus 2.5 plus 3 plus 2. So that's 5, 6, 7, 8.5. So the area of all these guys is 8, and these are yards, so 8.5 yards squared. So that's our estimated area. Again, if you did it and you got something like 8 or even 7.5. Again, you're doing it right. You just kind of got to find the right, maximize the shapes as much as possible. So 8.5 yards. And then if every yard costs us $6.50, what do we need to do? We need to just multiply this times $6.50. So we'll crunch that out and we will be done. 8.5 times 6.5. Oops, not 65, 6.5. And so we get about $55. It says, find the cost of the grass. $55.25 is what I'm going to put. Okay, $55.20. So a good deal for grass, maybe. Okay, so there's your irregular. Filling in the approximation of a simple shape, usually triangles, circles, parallelograms, trapezoids. You're not going to do something like an irregular polygon on those, and then adding them together. All right, please let me know if you need help. No, there's not going to be any assignments on Friday. It's a catch-up day, but we will be having a quiz on Monday. Quiz 9.1 to 9.3 on Monday. So be ready and reach out because I'd be happy to help you. Hope you're doing well. Jesus, Jesus, and more Jesus.